So we're going to skip bias in data collecting and sampled size and reliability. We're going to do those two in class because they require a little bit more discussion. I don't want to just give you the answer so that you're like, what? Okay, so we're going to actually talk about those together in class. So we're going to move on to margin of error. Okay, we're going to do these two examples. So this is where the calculations start coming in. So margin of error is actually pretty easy. So the margin of error in a random sample defines an interval centered on the sample percent where the population percent is most likely to lie. So sometimes you'll hear like Gallup polls, like when elections are on, they say, we surveyed this many people and 37% say this with a margin of error of 1.5%. Maybe if you're paying really close attention, you heard them say that. That means within 1.5% on either direction of that percent, there could be more or less people. Okay, sometimes math isn't perfect. Sometimes a sample is not accurately representative of a population. So that's why they give a margin of error. Okay, and how you calculate the margin of error is, so MOE, margin of error, is plus or minus 1 over the square root of how many people are sampled. Okay, so to give a little visual on this, let's go scooch in. This right here is our sample proportion. So we surveyed this many people and 45% of them say they like dogs. Okay, let's just pretend that that's what they said. Okay, from 42% to 48%, this is the range, or a likely range, for the true population. So this is just a sample of people that we would like to represent the population. Okay, 45% of our sample said they like dogs. Between 42% and 48% is probably a likely range for the actual population that say they like dogs. Okay, on either side, I'm going to use a different color for this one. I'm going to use purple. So from 42% to 45% is minus 3%, right? And then from 45% to 48% is plus 3%. These here, this is your margin of error. So in our little pretend poll, we could say 45% of our sample said they like dogs with a margin of error of 3%, which means 3% below our sample proportion and 3% above our sample proportion. Okay? So that's what margin of error represents. It gives you a range of percentages that's probably true for the whole population. All right? So, and it's really, really super easy to calculate. Plus or minus 1 divided by the square root of how many people you sampled. So let's do some examples. Let's do number 5. A poll reports that 45% of voters favor the governor with a margin of error of plus or minus 3%. Much like that in an election campaign. Estimate the number of voters in the poll. So this time, they give us a margin of error. We have to calculate n. We have to figure out what n is. How many people did they survey? Okay, so they give us our margin of error. So our formula, MOE, equals 1 plus or minus 1 over square root of n. They give us a margin of error of plus or minus 3%, which was, we want that as a decimal. It's 0.03. We set that equal to our margin of error formula. We don't actually need these plus or minus when we calculate how many people there are, so we can just cross those off. So I want to get n by itself. I'm solving for n. That's the whole point. So I'm going to multiply both sides by the square root of n. Okay, so I'm going to come over here now. So over here I have 0.03 times the square root of n equals 1, because those cancel. Now I'm going to divide by 0.03. And I get the square root of n equals, this is where a calculator is really helpful. And I have to go, actually I'll just use my phone. I can't use my phone because I'm recording on it, dang it. Well, this is like 33.33. Okay, approximately. So now to get n by itself, I have to square both sides. So n is approximately, well, 11, you should have gotten 11, 10, 89. So we're going to round up to the nearest 100. So it's approximately 1,100 voters. So that's how you figure out how many people are in a sample based on the sample, or based on the margin of error. Okay. Let's see, I'll use green for this next one. So let's do it again in number 6. Estimate the sample size for a 1.75% margin of error. Okay, so here we go. MOE equals plus or minus 1 over square root of n. So we're doing the same thing we did up here, only we're using a different number. 1.75% as a decimal is 0.0175 plus or minus. We set that equal to our formula. Again, we really don't need the plus or minus, but I still want to see you write it just so you know that it's plus or minus. Multiply by square root of n. So you get 0.0175 times the square root of n equals 1. Okay, divide both sides by 0.0175, 0.0175. Square root of n equals 57.14. So if we square both sides, n should be approximately, should get 3265 point something. Again, we're going to round up to the nearest 100, so about 3,300 voters. All right, so hopefully that makes sense for margin of error. In the next video, we're going to do number 7.